Bismillahirrahmanirrahim. Assalamu alaikum and welcome to my channel. Today I would be explaining all the examples in this chapter number 7 that has been taken from AVR book. And in this book of chapter 7, its name is AVR Programming in C. In this AVR book, first chapters were related to the programming of assembly language, and now I would be explaining it in the C, and it's converted into C. In C, we would start with simple programs, and then we would further move ahead and explain each and every example of this AVR instruction. I would also be showing you this on the some of them on the Proteus simulation or Atmel Studio simulation, that the explanation should be done more easier. But as per given, there are a lot of examples, and all the examples could not be solved on AVR or Proteus. But I will try my level best to explain each and every example with the logical comeback for you. So let's start first of all. First, for example, our example number 1. Now the given question is, write an AVI-C program to send value 0 to FF to port B. Okay, in this example, it is that we have to display values from 00 to FF, hex values in on port B, that their value should be displayed from port B. So how is the code? This is a standard library header for AVR that include AVR /io.h. This is a common header, and the last would be return and mean into void. This is a natural kind of syntax for C++ language or C language. In C, we write include IOStream, and in this C, we write for AVR systems, we write include AVR/io.h. Int mean is the same way void is added, and then we write unassigned character Z, because in this is character Z is unassigned. It is not assigned yet. An unassigned character would give a larger terms of numbers that we could include instead of writing signed number. As you know that unsigned include both positive and negative, but whereas signed include uh, has problem with it. These unsigned and signed has differences in the positive and negative terms included. So unsigned, we have included unsigned. So first we have given direction DDRB to the direction to port B, that is it is taken as output, as it all values are 1. If we want to take someone as input, we write DDRB is equals to 0 cross 0 0. That means it's all the bits are 0, and 0 is an input term, and 0 cross FF means all the values are bits are 1. That means it's a output. Now moving forward, we have taken a for loop. Instead of writing every one that port B is equals to 0, port B is equals to 1, port B is equals to, instead of that we take a for loop and create a for loop. In this we we initialize the character as we have initialized before, that is Z. We now give its value is the starter condition, give its condition as if the Z is equals to 0, in that it's smaller and equal to 255. That is the highest range of it. 255 comes from, like it's a 8-bit computer, 8-bit system that we would be using over here. So in this 8-bit, 8 raised to power 2 is 256. 2 raised to power 8 is equals to 256. Then but when we are taking from 0 to v0, it starts from 0, so it is 1 digit is minus from the end, and it becomes 255. So then we have given that the value of Z should be increased as the circuit goes. And then we have displayed the board Z value in the port B. So this loop would be continuing from starting with the value of 0, Z value 0 to 255 till 255, unless and until this loop will just remove around it, and port B would display the value, then return 0. Now let's see this code on Atmel Studio and on our Proteus. You will simply go to Nicel, and this is a website where you can get the pre-written codes instead of making them by yourself. This is our book, AVR books. We'll go to the seventh chapter over here, and you will click to source codes. Sometimes the placement of the codes are different, like one is given before, two is given afterwards, but like two is given afterward, three is before. So in this, but you can see the name from here. We simply go and copy this, and then we'll go to our Atmel Studio and open it. This is Atmel Studio is a great version for writing AVR and Arduino codes, and it helps us to enhance them and also have a variety of ranges from which we can write it. Okay, our window is open. We'll simply go to File, Add New Project. I'm writing C, and this is executable language, executable code. I'll simply go. I'll write its name as project video explanation. Now after this, I'll simply see where I have to place the window video, and then I'll say OK. Now here I have to select my area. I'll be selecting 18 mega. You can select Arduino as well. There is no um, no difference. It all depends on what working you need. Arduino has less pins that's why I would be preferring. Sorry, it's not. This is Arduino's pin at Mega 328, but I'll be liking 256. But Mega has more pins and it becomes easier for us to use it. So this is my 1 to 18 Mega 2560. I'll simply go to OK, and my project is created. As you can see over here, my project is created, and in project all there would be written when the computer created it, which was the name and which computer created it. Then it's include avr slash io dot h. That is the common header file for uh, the our AVR programming. I already told you, and then is int void, and then there is while. This is a common syntax for it. I just simply go. I don't need the while, and I paste the code. But this code is complete, so I have to just go like this. I just simply delete them. Okay, so this code is on. So I'll simply build solution, and you can see it's built it. Then I'll go debug, start debugging. I'll select my simulator. Yes, continue. I select my simulator and I go simply here and step into. Now, for the working of it, I'll simply go to debug, open Windows, and go to registers. So I can see the registers and what is happening in the differences over here. And I also go to debug. Then again, for checking the IOs, if I want to check the IOs, I'll simply go here, the IOs placed. I'll simply port P. Right now I'm working on port P. So I'll just copy it and here. I'll also be doing it like this. And let's step into it. First one it was 0, so let's step into it. You can see it is FF already because we have given the direction. TTRP means it has taken it and it has given it, stated it as is output port. Then I go to 0 and it has detected that something has happened. And then I'll go to step into again and you can see it changed the value 0. First one was 0. Let's stay ahead. Here 1 is red now, and you can also see resistor 24 is showing 1. That means that my first value is being displayed. Then the next step 2, you can see over here this is 1 pin 2 4 8 16 32 120 126 125 then 255. Just like that it would be going ahead. 3, both this and this. So now let's see this on Proteus. Code on, to make our Proteus file over here. First of all, what we would be doing is we simply go to new project. Easier way is that you simply select this from development board and select 80 mega 2500. That is our project. Name the project as Windio explanation and here, and I'll choose the place where I want to save it. I usually save it in a F drive. It has its folder because it's get really hectic and the amount of software is installed it gets hectic. So look here EVR sorry my Arduino 250 is already made with its all circuits. The next step what I would be doing is I'll needing LEDs. I would be using red LEDs. Let's see. Yes, I use this one LED. Then I would be needing nothing else. So let's see. I'll simply be placing them over here. I need 8, so I would be placing 8 over there. 1, 2, 3, 4, 5, 6, 7, and last one here. Oh, next step what I would be doing, I would be taking the pins. Now for writing an AVR computer, you must be careful what kind of pins name you are using. If you have used port P, then make sure you see its configuration on the pin configuration from the pin chart of pin configuration chart available on the internet, or see the data sheet for it. If you have chosen different pins and you have written different words, different names, then this would not be giving a correct answer. So let's work on it, on making them. Okay, I have to do this again and again, and then I'll be moving them to the right place where they belong. You can either simply be deleting all of this and simply be connecting it with it, but it's look kind of messy and it wouldn't be able to easier way to explain it. So if I just set it once, so I don't need to be doing it again and again and to because ahead when we would be doing circuits, it would just be needing a little bit of it and it would be explained. Look, done. Okay, so now our pins are ready and our circuit looks quite well. So I would be explaining you something and then we would be further moving ahead because we have a lot of examples to cover. And once we have made a circuit, mostly the circuit is almost the same. and we don't need to be doing making again and again. We would just be uploading the hex files that are different. Instead, everything would be the same. So we just need a ground here, and we are good to go. Okay, so over here we have a lot of pins. So you cannot be able to identify which is Arduino port B. Either you can see over here the first letter, like this is PB0, this means this is port B. This is PC0 means this is port C, this is PD0, this is port D, this is PE0, this is port E, this is PF0, this is port F, this is PG, this is port G, this is PH, J, K, and L. But I think you can simply, but if you don't want to take the risk, you simply go over here and you select pin configuration of Arduino Mega. Just simply go and you can see over here that how it does looks. So when we would open over here, this is the Arduino Mega. This is how it looks, and this is explanation, some of the explanations given about it, and here you can see its pin configuration. So looking at it, we can get I'll be closing it up. PGDGDD. Okay, so it would be 53, and you can just find over here and you would be able to get it. So is my value of this is 50 starting from 53. Look, this is PB0. That means PB0 means B port is started from 53. So you can check it over here as well, or you can have the data sheet that you have given. So I'll simply be changing it. So my PB my C is over here IU53. IU53. The next one is, I'll tell you why do you write, why shouldn't you just remove them and just simply go it over here. IO52. We these names are very much important because when setting the circuit, some of the pins are really difficult to find. Like over here, it is like written over here. And if you just remove all of them, it would be very difficult for you to construct a circuit because in this over here, it is written as IU51, IU52, IU53. But over there on the Arduino Mega, it's very difficult to find which pin is the port B1 because there it is not written as PB0, PB1, PB2. It has written as 50, 51, 52, 53. So over there, this pins configuration becomes very much easier. This PB50, PB IO50, IO10. So you just find you just find 50 and you go there, and 50 is the IPB 0. You know it. So this that is why it becomes very easy for just by having these PBs that you can identify that which value it is. Okay, done. Done with the second one. Now what I'll do, I simply double click it and I'll just search from a file which is usually present in my C drive user MVT documents. All the in your case it could just be simply in your documents. So my name was video presentation. I just simply find it from here and it's there. I'll go here, I'll double select it, debug, and here its hex file would be present. I simply clicked it. Okay, and yeah. So it is moving so fast that it would simply go ta 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 ta, because there is no delay in it. So either I could put delay in it and simply move it little slower, or for the whatever it moving it, because here you cannot see it correctly, because if they are just moving so fastly that you cannot be able to see that what is the difference created over here. So to this, the solution could be that I could also add delay function in it. I'll be further explaining delay function ahead in this example tutorial. I would be also going towards delay and timer function, but for up to now, I would be leaving it. Now I have shown you how to create a family, how to get the codes and everything. So I would move moving back to my example. Okay, so our example, this was done, and it would be ultimately its answer would be 55. Now it's example 2. Its example says that write an API C plus code that has the value of ASCII value of characters from 0, 1, 2, 3, 4, 4, 5, A, B, C, D, and E. Means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So, and we have to explain, we have to get all of these ASCII code in from the port B. So, what we have just go to the, just go to the code, get the code, and we have just created an array that has the value 0, 1, 2, 3, 4, A, B, C, D. And then we have created an array that we have created. Why we have created this arrays, these two characters, I'll show you, I'll explain you ahead. Then we have given the direction to the port B, that it is output port, and all bits are 1 over here. Then I've created a z for loop, and here you would be seeing the example, the usage of this z character that I made ahead, before it. I initialize z value is equals to 0, then the value is less than 10, and z is plus plus. Why is z value is less than 10? It's 10 times increment. Means we have to write 1, 2, 3, 4, 5, 6, 7, 1, 2, 0, 1, 2, 3, 4, 5, and then A, B, C, D. This 6, 7, 8, 9. So it makes a combination of less than 10 characters. Less than 10 characters, so that's why its z value is less than 10. So that means all of these are implemented. If we do not write z less than 0, and we write it equal to 0, then there would be an error occurred, because after the 10 as a d value would be displayed, it would still go still, because it would not be having the 11th value. And so this we have also placed z plus plus, which means increment, and then we have displayed in port B and my list and z. So this means my list, and with the character z, my list 1 is 0, my list 0 is 0, my list 1 is 1, my list 2 is 2, my 3, 4, 5, 6, 4, 5, A, B, C, D, and while character 1 and it turns 0, it's a closing statement. Then the third one is that the write a single AVR code to toggle all the bits of port B as 200 times. Now toggling around toggling at ports means, toggle means to blink, to go one to go bright and dark. So here we would be toggling it like 200 times, like 200 times it should blink. So this is a blinking code for port B LED, and we would simply be blinking over here. So in this, what has happened, like it has to toggle 200 times. So what has happened is that we simply go to toggle 200 ms2 ps 200, include AVR, include main, that is a common one. Syntax, then we go direction, we give the direction of port B as 0 cross FF, that means that it is an output, and then we go port B is equals to 0 cross AA. And then we go to unsigned character Z. The way as in it we had initialized the value of port B as 0 cross AA. Now what is 0 cross A? It's 0 1 0 1 0 1 0 1 0 1 0 1 0. So it means like a blinking code. On off on off on off on off. But as we are using 8 bit, when we put 8 bits, it would be also be giving 0 cross FF, means blink 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 blink. I'll show you how it is. Then we have written a for loop for z is equal to 0, and then z is smaller than 200 and z is incremented. Then we have written toggle to port B is equals to inversion of port B. That is a toggle one. So we simply go to nicer than, we simply make a code and we would write it out nicer than. Now here's the Proteus simulation. As you can see, it is really fast toggling. It's really fast. That's why it's not being able to see. If and here's the code over here as well. And well, what I do, I'll just do also add a delay function that I would be explaining you ahead after the few examples. I would also be explaining you this delay function. So I'll simply go and write as delay underscore. Oops, sorry. I would be explaining this delay function ahead after this underscore also on my head. Delay ms, and then I'll go with um I'll be adding a delay of 250. Now some people write this as some other way. I write it like this, and simply I'll be going build again. They would be identified and search for that. There also is a delay uh, library that you have to include. So I haven't included it. That's why it is giving an array. Is and simply add and then I'll show you. Okay, so here you can see the code is created. I have added define fcpu 8 and how 8 zero 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 ul. So this is a defined library. You have to include it if you want this delay function to work correctly, and you have to also add this header file of until delay.h. This is a built-in library header file that is included and made for the AVR processes, and so you have to add this delay ms. I will be explaining this in detail ahead from the end, because in the coming examples we are going to be having a topic of delay and time delay, and we would be using it. But still, just to understand and to make this answer clearer, just make the toggle easier, I have added it. So now I hit okay the toggle. Now you can see it is going really slow, so you can be able to understand it. First it was 1, then 0, then the 2, then 0, 2, and then both. And then this was 3, and then this 2, and then this would be going like a toggle which switch. It would be toggling, and then it would be going 255 times. Arduino board B has only 6 pins, so that's why it is. Yeah, I've shown you on this six one, but if I add two more, you would also be able to see it. Wait a minute, I'll be adding it and then I'll be showing you the difference. I'll simply go add two more to just make it 8. Edit these. These last ones are not, although are not the pins for like port B pins, because in Arduino Uno, this is Arduino Uno code and this is Arduino Uno, but they are not efficiently be used because as they have lesser pins as compared to the Arduino Mega. So let's see. But still it would be working absolutely fine because the first ones are going ahead, and then like this it would be going ahead. So next I'll be moving to the third example. That is, third example is done, so we will be moving to fourth example. In the fourth example, they what have they done that they have the program sends values of -4 to 4. Okay, so over here you can see we have created a character that is Z and saint unsigned character, so it means it is already one. Now for this you have to understand the difference between unsigned and signed bit. You can get its example over here in this very efficiently, and you can easily understand it that signed has from minus to positive, has both values negative and positive both, but unsigned has only from 0 to positive values. That's why it's different from each other. So in this we have unsigned value, that means it has only 0 to positive values, positive infinity values. Then they have given it direction DDRB is the direction port B is 000 cross FF means we have made it an output port. Then we have again used a for loop, and then we have made that it would toggle 8 times, because in this when we have made this character n, that is an array that has 1 -4 -3 -2 -1 0 1 2 3 4. This has the same value. Okay, now if you see in the previous one we hadn't put an equals to sign after lesser than, but here we have used that equal to sign, means that it will also includes in it. And then we have a simple increment and the board be my num z, and it would be going from -4 to 4. So it would be displaying all of this on board B, and one by one, one by one. You can also add the delay function that I'll be explaining ahead and that I have also used in the previous example right now. We can also then our next question is that write an AVRC program to toggle all the bits of port B 5,000 times. Now this is the same question that was in the first one. It was 200 times. Now it's 50,000 times. But what is the difference? So in this 50,000, we would be simply going same the unsigned character Z, then we would be DDRB is equals to output port. Then the for loop is again in the process as, but now the value C is smaller than 550,000. And then Z is increment, port B is equals to 0 cross 5 0 cross A. Now what is the difference? Why did they add 0 cross 5 and 0 cross A? So I'll show you something. When you search the value of 0 cross FFAA, you know get to know that it is 10101010. And similarly, if you just go over here and type it 0 cross 55 in binary, what is that has also the same value 1010101010. So this is the difference. Both have the same value. So it would simply it would toggle again and again for 50,000 times, and this process would be ended. Now next is that the write AVI code to toggle all bits of port be done 1 lakh times. Now in this, instead of integer, because integer do not have this limit, we use long character. Instead of using long command, we instead of using that int command, we use long command because we need greater range of numbers. Every command has a range. Float has a range, double has a range, int has a range, and even though this long has a range, but long is a very vast number. That very big number can be included in this long one. So this is the only difference over here. But otherwise, both the codes are same. Then we have skipping to the time delay that I had done before. So this in this time delay, what happens that we have write a code of C++ program and toggle all the bits of code be continuously with 100 milliseconds delay. So the first code that I had written for above the previous one that I had written with the toggling one, that also is moving over here down over here. This one, it I should wrote its delay function for the 250 milliseconds, as I had done over here. You can see over here as well that is written delay ms 250. So it has 250 seconds delay. But now we want 100 milliseconds delay, and it also gives us a condition that assume that the system is 80 mega 328 with x tall is equals to 16 mega. What is x tall? This is a crystal. This is crystal's name XTAL is equals to 16 megahertz, and this is its frequency. Every crystal inside an Arduino comes with a frequency, and this crystal's frequency is 16 hertz. This 16 megahertz, this 16 megahertz gives us the value that how much bigger the crystal, the delay value we have to put, and how to set its value. So for writing a delay code, if you do not want to include the direct header file of no, what I was explaining before that if you do not want to include the direct built-in header file of delay function, you can also create its file. It's in different function. So here we have created a different function. To create a different function, we have written void delay, the name of the function 100 milliseconds. This is the function that we have created. Then void as it is written in C. Then volatile unassigned long I. We have declared the number of the declared I integer in a long one assigned volatile. Now volatile is written over here. This means this is a volatile, and we have included its condition is I is equal to 0. I is smaller than 4,706 7 470 then an increment of I, and this function is done. Now, what is this? It is trying to different values, number of values for your compiler and examine the results. Now, this value, this 47060 came from here. This value. It came from here, the value of the XTL 6 equals to 6 megahertz. This value came from here. And then we have written an int main void. The main function declare the value of port B as 0 cross FF means it is a output port, and then while one in this while one function we have written as port B is equal to AA. Now declare the value of port B is equals to 0 cross AA for toggling, and then we have used the delay function of ms 100 ms 100 ms that we have already made over here, and then we have written port B is equals to 0 cross FF and then delay 1. So this is the function that we have written before over here. We have simply just done one thing, that we have included 0 cross FF over that delay function over here. So after the delay is done for this value, now what we would be moving forward to the next example, that are exact example. Write an AVR C program to toggle all the pins of port C continuously with 10 milliseconds delay. Use a predefined delay function in Atmel Studio. So first, in the first one we had made the function, but here we would be using the predefined Atmel Studio or the Studio header file. So here we would be using the first header file. I've already shown you until and util divide slash delay dot h. This is a predefined header file for the delay function in used in C coding in Atmel Studio. Then we have also defined an f underscore CPU 16 UL. So this is the value over here, and included the IO stream, the header file, the AVR that is already there, AVR slash IO dot h. Then int function, we were simply doing the same to same function we have done over here, and you can see the results would be exactly the same. Exactly. Then we have move ahead, and then we would move to our say, example 7 cross slash 9. LEDs are connected to the pin of port B. Write an AVRC program that shows that the count from 0 to FF. So in this on the LEDs. This is the same one given in the start one, but now it would be for the delay one. The one that I had done already, this one. And this one includes a delay, as you can see over here. It has the delay of 500. I have to just change it and add 0 over here and go same to same function. You can also see it, check it out over here. It gets wise, but instead we have to board connected LEDs are connected in board B, write a program C that shows count from. Okay, so in this, instead of toggling, we have to write a count function. So what we have to do is, instead we just port B is equal to 0 cross F, first one 0 0, then we would add the 0 cross port B is equal to port B plus 1. So this have to be done for like until it is 500. That until its value, the counter values FF, that is all of them are 1. So already we have already declared that the DDRB is 5 for the output on the while one, and let's see how it works. We simply go over here, we take its picture, and we go like, we simply remove this as well, and copy this. And then we simply write port B is equals to port B plus 1, and then same. So this is a function done. I hope this is the same function. So let's see. Yes, it is the same function. Just instead of this, we would be adding a 60. Then we get built. Okay, that is a code I had already done it, so it is also compiled. And we simply going over here and stopping it. I'm already talking. I'll simply go upload the code that I've already created and play. Same code going. First is adding, then it would add this as well, then 2 it would be, and then 5 because it is 500, so it is a double 0.5 seconds delay. It's too much, so the it 2, then it would be 3, then 4, then 5, and then it would be going so all. So next we would be moving to the next example. So this is an example next, that is strength, that is that write an AVR code C to get a byte of data from port B and then send it to port C. Now this is a switch and program, switch and display program, that we take a value from one port and display it in the other port. That's the value. Now what would happen, like we simply go to AVR and then the int void int main void in unsigned character temp. Then we declare two ports, their directions. One is direction is 0 cross 0 0, which means an input port, that is DDRB. So B is the input port. Then DDRC is equals to 0 cross FF, this is the output port. And while the temp is equals to pin B, and then port C is equals to temp. Then this is the conditions we and the logic we have made that the temps value is pin whatever the value and pin B would be given to temp B temp, and then the ports whatever the value of temp would be, it would be the value of port C. So this is simple code. Now what is this? It simply goes like this. Like I just intent. You simply go and copy this code out. Copy. So in a total we have 37 examples and we are on 10. So inshallah we would be doing it. Acha. So we simply go over here. We'll copy paste the code. Build it. It's built it. So now what we're doing is that I had already made this exercise before, so I'll simply opening it. So I have made a change over here. I had made the port so T already selected, so I just didn't want it to redo again and again, so I simply added instead of port C I added T. So this is our circuit. I simply pressing it out, selecting our um, program, and then after that, I'm sorry for that. Okay, so see over here, it is our core circuit going on. So if I on this one, so it would also be offing this one. You can see it's a gray voltage. Yeah, I have some kind of problem with my protein, so it doesn't work correctly. But it is a right circuit. So it simply goes like you just on and off these circuits, and you can see the differences. A protein circuit is not protein simulation is not working right now, but it is alright. You see that I closed this and this one voltage which this one LED which was not working previously, it started working. So it is the same. You can see over here it is red, so this red goes. But as you can see over here, this is giving gray voltage. That's why it's not being implemented correctly. But the logic prompts show the right result that all of them are 1. So let's stop it over here. Okay, so we were going back to our explanation. Then now over here, what we have done that in the example number 11, write an AVRC C plus code program that to get a byte of data from port C if it has less than 100. Send it to port B, otherwise send it to port D. Now, in this, all the 3 ports are being used. What it says that we have to get a 1 byte answer from port B from port C. That port C is an input that I have already given. Over here is the DDR direction. DDRC is equal to 0. This means all the bits of the port C is 0. But over here, we as mentioned above, it is a byte. Means that 1 byte is only involved in one switch or toggle would be included to port C, and the resulted output it would affect both port C, port B, and port C. So what would be if the value of it would be less than 100, then it will send it to port B. Otherwise, it would send to port B. D. So this we have made a while function. We have characterized that given the corrected direction of port C is equals to 0, that is input, and port B is equals to 0 cross FF. Then port D is equals to 0 cross FF, which means that port B and port D are both input or output ports. And then we have to made an assigned character of temp is equals to the temp. Then the while loop again we have used, and then we have to say that temp is equals to pin C. Whatever the value of pin port C would be, it would be pin. Then they have given that if temp is smaller than 100, then we would what would we do that port B is equals to temp. Then port B would be displayed. Otherwise, if it is the not is equals to 0 greater than 0, it would be port D would be displayed, and temp is equals port D is equal to temp, then 0. This is an easy as program going on. So moving to the next one. Run the following program on your simulator and explain the results. So in this in this program, it's a simple example which is doing all of the function of and or not and all of them. I've already written this program and I'll be explaining how it works. Okay, so this is the summation for it. So what happens over here that we explain it to you to it that this was our code. So what happens first, it has taken the direction that all the three ports A, B, C, D, C are both or all zero processor. This is an Arduino code, Arduino Uno code. So that's why they had not taken A instead of A. They have taken D. But as I was using Mega, you can also take port D. But I have used port A to get a better simulation result, although it would remain same unchanged. But still, for the better use and understanding, I've used A instead of D. Since it has given port E is equals to 0 cross 35 and 0 cross 0F. It has moved an analog signal of AND function, and then port C has done 0 cross 0 4, then that is OR function, that is the symbol of OR to 0 cross 6. It has now these both binary values would be performing a or function or values like same the function like if it's both are 0 then it is 0, if both are 1 it is 1, if any one is 1 then it is 1, and then what C is equal to NOR function, XOR function, and it would be doing it as with these 54 and 78 values I have given overhead. And port B is equals to 0 in negative 0 cross f. This is inverting the not function of used, and then while the same loop, and then over here you can also see the results over here as well. In port B that has done the first it was AND function, and then it was inverting function, so it was inverted. Then in then port C it was OR function, port E it was toggle that XOR function, and it has translated through these uh, LEDs. It is such a fast process of function going on that you cannot expect. You cannot see the changes that are being done over here, but they are literally changing changes done when from the start to the end. So after that, next example. After that, we have to do the next example. That example number 13. Write a AVR C plus code toggle only 4 bit 4 of port B continuously without disturbing the rest of the pins of the port B. So in this we have to use only one pin instead of all the pins. Like first in the start we have used all of the pins, 8 pins that are available, 6 pins that are available, but now we would be working with the single pins and we would be using single pin to give the input or output. So here this the code goes. The same syntax for the C, C, C++, AVR, head 5, and then int main. I wouldn't be explaining it again and again, but it would be very necessary while function and return. So after this, what is the main function would be that we could either be using a different methods with CBR or IBR, but over here another method is the port B or function 0 0 0 bit 0 0 0 1 0 0 0. So port B is all zeros and there is only one zero in the middle of the one, that is fourth one. This is fourth bit of port B and it is 1. So if only one is if one is 1, if both are 0, like over here in all function what happens that If any one is one, it gives a one an answer. Okay, so in this we have only one, and support B is obviously 0 cross FF. That means it's all 0. So it would give it a 0 bit. But then in the all I want, and it would be giving that one. It will giving only have here. There would be a difference created and answer created, answer given. But in port B, that port B is add function 0 0 1 1 1 1 0 0 1 1 1 1, and the fourth bit is 0, and when there would be 1 1 1, and call ahead, if there would be only zeroth fourth term of it, that would be un changed. That would be toggled. Okay, so let's move ahead. Then there is a function that write an AVR code C program to monitor if bit 5 of port C. If it is high, send it to 0 cross FF or to port B. Otherwise, send AA to port B. So what had happens? It compares to that if one is high, then if it is it would port B would have port B when would port 5 bit port C would be high, then it would be giving 0 cross FF, or other port if port B pin 5 of port C would be low, it would be giving 0 cross A to port B. So let's see. So what would we do that we would be making a direction, so we would be given direction in port C, it would be given the direction of input, other would be output. Then while function again, then if port pin B is and then 0 cross 0 1 0 0 0 0 0 0, that is the 15. Monitor bit 5. Okay. That would be monitor bit 5, and it would be not equals to 0. That means it is high. Because genuinely, because it either it could be high or low. It's not high, then it would give 0 0 and 0 0 A. 0, it's not z is equals to 0, then it's not equals to 0, then it would be giving the port p value displaying view 0 cos 5 5. So it is the correct answer, because the fifth bit would be the sixth bit would be 0. So 1. So the next one is that if else the board B would get 0A. It's a simple program and it is working absolutely correctly. Then there is a suppose example 15, that is a door sensor is connected to a bit 1 of the board B, and the LCD is connected to pin bit 7 of the board C. Write an AVR program to monitor the door sensor and which it opens turns on the LED. So this is a simple code that is written. It is in this question. It is asking that we have tried to write one bit port, the 1 bit of port B, and the LED connected to the bit 7 of the port C. Okay, connected with one of port B, and the LED is connected to 7th bit of port C. It has given us the values. Door sensor is connected to 1 bit of port C, and the LED is connected to the 7 bit of port C. Then they write an AVR code to monitor the door sensor, and when it opens, as door opens, it turns the LED on. Acha. It says that as soon as the door is open, the LED is turned high, and the LED is on. As soon as the door closes, the LED shuts down as the voltage as the sensor detects as 0 and it's low. That is the same code. That is what that was about. That it was high and low. It is the same, or working on the same process. First, we would be giving them their value, initializing them their values. Then we would be they commanding that if else statement, that if port be 0 0 0 0 0 6 bit, as the LED as the sensor is on the first bit, so it would be 0 1 0 is not equals to 0. Then the port C is equals to 0 as it is on the 7th bit, that is 0 0 0 0 0 1. So this would be it. And then because this is a 0 bit, 1 bit, 1 bit is on, and then it would be going on. Else if it is not, then it would be port C is equals to port C and zero zero. So this port as you port C is already this, so the only seventh one will be open, eighth bit would be open, and this will be closed. Otherwise, this will okay. So moving ahead, then it would be port if pin the data pin of the LCD are connected to port B, the informations are latched into the LCD whenever an enable pin goes on high or low. High to low, the enable pin is connected to the pin B or pin 5 of the port C. Sixth pin, that is the sixth pin because always consider one bit ahead. Right, CP is programmed to send the faith the Earth is but one country to its LCD. So now this instead of LED, it's an LCD code. Now what is that? That the data pins of the LCD are connected to one port. Port B is connected with the LCD, and the data pins are connected to port B. Now the information is latched into the LCD whenever its enable pin goes from high to low. Now whatever happens, the information from goes from high to low inside the LCD is given by the enable pin. The enable pins are connected to the fifth pin of the port C. The port C's fifth pin, that is the sixth pin. The sixth pin is connected to port C. Write a C program to send the Earth but one country to the LCD. Now this is the function we have to write. Okay. So for this, first of all, we would be making an int main unsigned character message. And the message that we have to print, that is the Earth is but one country. We would be typing out over here. Then unsigned character, we would be getting again unsigned character, and then we would be characterizing it as C. Because we have to display it all. So then redirection of port B is equals to 0 cross data, that is an output port because port B's all data pins were connected to the port C. Port so the next one is that we initialize the direction DDC is equals to the DDRC or 0 cross 0 0 1 0 0 0. So it has all our zeros, so only this sixth pin is open. That is pin 5 as given in the question. Then it would be for z is then we would be making a for loop, that is z is equals to 0, z is smaller or equal to 28, that is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28. It's less than 28. I counted one ahead, so it is 28. And then Z is plus plus increment. So after that, we have to display that if port B is equals to message set, and then port C is equals to port C is or that the same we have done over here. And then we would be doing it port C is equals to port C Z is and port Z. So for now, what would happen that when this happens, it would be giving a high logic to enable pin, and when this happens, it would be giving a low logic to enable. Why is it happens that first when the LED message is sent, the LED ons, and enables pin goes to high, but as soon as it has to close it, means after this once the message is done, it is completed. So now it would also giving the enable pin to low. So this happened all over here. Then after this, an example over here is that 17.7 that write a AVR code in this read the pin 0 and 1 and 0 of port B and issue an ASCII character to port D according to the following table. Okay, so they have given us a table in which we have the numbers that we have to display at port D according to the whatever the pattern is coming from a 0 and 1 pin of port B. Now we are actually working on pin configuration, how to display it. So we would be using this. So in this, this is a table. If both are zero, then it send zero to port D. If a port pin zero of port B is one, then it is would be one. If port if pin two is one, then it would be two and only. And if all are one, then it would be a three value and T. 40. What will include AVR same value include it has an unsigned character set. It shows that the DRB is equal to direction of port B is 0, then direction of port D is 0 cross FF, while then pin Z is equal to pin B. And we have declared that the Z is equal to pin D, B, and Z is equal to Z and 0 cross 0 0 0 0 1 1 means that only two pins are involved in this of port B, and that is 1 1 last two pins. And because it's sad, so only the both are equal, then it shows the result. And as we have seen that a 0 cross f meant all the pins of port B are 1. So when and Z is also B, so port B, so it has that all the pins of Z is also 1. And when it collides with this binary number which is only 2, so it's a 3, which explains that it would be giving us only the last two pins would be inactivate. Now it has made a switch statement that we make in uh, Arduino C language, that if in this there it has different cases, that if Z1 is included, case 0 is that port D is equal to 0, break. Then port case 2 is port D is equal to 1, then port second, third, fourth, and like this it is done. And as it depends on the value of the z, that whatever the value of z comes, it would give the same case as it is given. Now you can also make a code that if the input there would be a place from which you can input the value of c. So let's move ahead. Write a CVRC program to monitor bit 7 of port B. If it is less, it is 1, make it 4B. 4 of bit 4 of port B input. Otherwise change pin 4 of port B to output. Now in this program we would be initializing one pin of port B to be either be positive, either be input or output. What we do, we send direction of DDRB is equal to DDRB and 0 cross 0 1 1 1 1 all are 1 except for the 7th pin, that is the 8th pin, because zeros are also included in it. So this would what would happen would be that it would be given us that 0 cross 1 1 1. So after that, okay, so what we would be doing is that we would be taking DDRB 7-bit port should be only the one. So 7-bit port would be only initialized over here because both would be 0, and that's why it would be initialized. So means it's only active. Then after that we would be if pin B is and 1 0 0 whole letters of 8 numbers, 7 the zeros, DDRB is equals to pin B, then port B is equals to DDRB is 1 1 1 0 0 1 1 1 1. So it gives a 4-bit answer. 4-bit bit 4 of pin B is input. That is the 1 1 1 1 1. That is 0 1 2 3 4 are positive. After that, then if this condition is not true, then it would go to port B, and port B is or connection 0 1 1 1 0 0 0 1 0 0 0. That would be only if all the 4 bits are output. Okay, then moving ahead. Example 19. Write a CVR program, that a C program to get the status of a 5-bit port B and send it to port 7 of the port C continuously. Now in this code it says that if we are C plus going to code that to get the status of port 5, status of bit 5 of port B and send it to bit 7 of port C continuously. As I've done this type of example, I've done it ahead previously as well, in which but there was only one pin port from one taken and one bit any of the LCD1 that one sensor detects detects the door opening. The sensor gives a high logic and it would open the LCD LED. So just like this, in this, if the when bit 5 gives a high logic, it would give a high logic to port 7, pin 7 of uh, the circuit as well, of the port B as well. Port C as well. So it was simply we would be firstly declaring direction right, and we would be enabling their only one pins. First for the port B, we would only be enabling its fifth pin, and for ports that fifth bit, that is sixth pin, and for the port C, we would only be enabling its seventh pin, that is the last pin. And then we would be if pin B is 0 plus 1 1 1 0 cross a 0 b 0 0 1 0 0 0 0. So this would give the port C is equals to port C or 0 cross 0 b 0 0 0. So it would as port C would be giving seventh input as high. Otherwise it would 0 cross 0 1 1 1. So it means that it would be giving only the LCD off. Now it's a code examples 20. Then write an AVR code to toggle all the pins of port B continuously. Use the inverting operator. Okay, so this code has already been done for head first before as well. That all the pins of pins of in the port B are toggled. We simply we put the value for direction. We give direction to port B at 0 cross f, then we we initialize its value. 4b is 0 cross a, and then while one we write the port b is equals to or inverting port b, and that's it. And then for the use the XOR operator. Now instead of the inverting operator, we have to use the XOR operator. In XOR operator, it would be simply the program before a while one would be remain the same, but inside port B, we would write port B is equal to port B. Uh, or 0 cross ff. 0 cross ff all value is 1, so when in XOR value would be included, it would give a toggled answer to it. Then example 21. Write a bitwise bitwise compound assignment operator. Rewrite examples 20, 7, 18. Okay. Now whichever the example of 718 was, we have to rewrite it and we have to make an entry circuit that of with the compound assignment operators. So what would we do? We simply do that. We give the direction to DDRB and is equals to 0 1 1 0 1 1. Now why did we do it? We have to go back to 7 cross 7 slash 18 example, and that is what here, and it monitors as seventh bit. So that's why, and fourth bit of okay. So this was an example. So so it was seventh pin, and all we have done bit five of port B is input. That's why we have taken direction B and is equals to we can also write direction B is equals to direction B, and but this is also a simpler way that just write direction B one time, DDRB one time. We give it a 0 1 0 B 1 1 0 1 1 1 1 and all the one. So 5 bit 1, 2, 3, 4, 5. 5 are 1 inputs. Okay, bit 5 is input. So उसके बाद after that is that bit 5 means fifth pin. So if the pin B is pin B and 0 1 1 1 0 0 0 B 0 0 1 1 1 1, so means if its answer is 0, because in this when we would exchange both, compare to and function both, it would simply rejected and it was all be 0. That means it would save to else function. If it does not save to else function, then ddrb is and is equals to 0 plus 1 1. So this would give us a 4 bit 4 bit of in port B instead of 5 bit, and if else it would give us 5 bit instead of 5 bit output instead of 4 bit in 4 bit output instead of 4 bit in. Then after that, rewrite the example 19. In the example 19, as you can see over here, the previous one over here, in this wait a minute. Okay, so in this example, we have to get a status of 5 bit 5 of port B and set it to 7th bit of source C. So what would happen over here, that we would take both the initialized support B and port C is because it was 7th pin is on and its 5th pin is on. Then after that we would write if pin B is and if pin B and is equals to its 4 bit then on, its 4 bit is off, then what would happen? That was we would set port 7 is bit 7 of port C is equal to 1, or else it would be given port C of says a bit 7 of port C is 0. Okay, moving ahead. Then this is example 22. Write a code to generate the following numbers. If a number that we in this example we have to simply give one line answers and it would be solved. A number that has only one in a position of tr7. In the 1 2 d 1 2 1 smaller than 7. Then 1 in the position of d2, then it would be one smaller than two. Then it would be the position in one in position four. Then it would be smaller than a four, and then it would be a number that has only a zero in position five. Now it's not four; it is one, not one. It is zero, and it would be inverse of one zeros, one double smaller sign then 5, and same goes to in all the three, then this one is smaller than 3 and one is smaller than 1. Okay, write a AVR C plus code to monitor the bit 7 of port B. If it is 1, make a 4 bit 4 of port B inputs, else change pin 5 pin 4 of the port B to output. So in this program, what it would be doing is it would first be initializing that pin 7 of the port B is inward, and then it would be checking it that if pin B and is and option 1 the smallest 7, then ddrb is equals to ddrb and inverse of 1 slash ff. So I mean D4 is it would be comparing of D4 over here and D4 as over here. Then it would be else it would be performing an all function of 4 bit. So means in the first one the 4 bit would be input, that's all of the 4 bit would be on, and but in the second one all of the input would be 0. So it means it will be an out. O means if all the pin of port B, I just mixed it up and I said it wrongly. That if all the bits of the 4 are 0, then it would be an input, and all of the bits are 1, it would be an output. And here the circuit ends, and then it would be example 24. Write a AVR C plus code that to get the status of 5 bit of port CB and send it to port 7 of the port C. So this would be the same to same example, and just we would be using these operators instead of those simple words. So we would be DDRB first initializing that 5 bit of port B is the input, and then initializing the 7 bit of port C is output. Then we would be checking it again that if the pin B and one smaller 5, then the or is equals to port C is or is equals to we would be form an OR function with underscore 7, and if else it would be inverting. Then after this, there's the question: a door sensor is connected to the board. It has the same to same question. Instead, we would just be using instead of that words, instead those words, we would be using these words and these symbols. It is exactly the same. One is if or if a statement one is correct, so it the LED would be on. But if not, it would be off. Okay, then this example 26. Right, just say if we have C plus code to convert the backed BCD for 0 cross 0 to ASCII and display it on the bytes of the port A, B and port C. Now what they are saying, they write a CR code that can convert backed BCD 0 cross 29. Okay, what would we do? We simply get to unsigned character x and y. Then we would be going an unsigned character simple as there's my bytes as 0 cross 29. So we have stored the value of 0 cross 29 in one sum of it, and then we would be going to port B is equals to port C is equals to 0 cross F. Means all of them are port B and also port C are outputs. And then word B X is equals to my byte and 0 cross 0 F. So means now it would be any checking for it. If he's alive or he has this thing to be in him and he knows what to do, so she's asking for help, and it would say, and would be saying DDRB is equals to DDRB is equals to CFF, then X is equals to my byte and 0 cross 0F. So it would be a mask upper 4 bit, and then port B is equals to 0x is equals to and x or function of x 0 cross f5. It makes it an ASCII value. 0 cross 30 is an ASCII value of so after that we have to also declare another variable, that is y, that we have declared above. Then we would be my bit and function of 0 cross f0 as 0 cross f0, and it would mark the lower 4 bits of the 4 bits, and then it would be going from y is equals to y underscore smaller than 4, and then it would be port 4 is equals to y, port c is equal to y 1 cross 0 cross 30. So it would also be initializing its ASCII value, and it would be good. Then after that, it's example number 27. Write an AVR program to convert ASCII digits of 4 and 7 and packed DCD and display on the port C. Now what would we do? We would be making three unsigned connectors. One is the port BCD byte. One is W is equals to 14. One is Z is equals to 7. W is equals to 4. So we have 4 and 7 that were given to given condition, and we would be using a BCD type byte for guidance and working. What first we would be doing, or we would be initializing the value for w, that is w is equals to w and 0 cross 0 f, and then w is equals to the 0 w but it's smaller than 4, means it is shifted towards the left. It is shifted towards the left and make upper BCD digit. Then after that, then it would be z is equals to z and 0 cross 0 f. Then it also marks it's in this process, and the rewrite BCD byte that we have used before is equals to W or C. That is a W would be compared with the packed one BCD, so that it could be packed over here. Then port B is equal to BCD byte. Whatever the result would be, it is that over here it would be given as BCD byte. And this is an example, a solving example that assume that we have 4 bytes of hexadecimal data of 25 25 hex, 62 hex, 33 35 hex, and 52 hex. Now, check checksum byte and perform the checksum operation to ensure the data in integrity, and if the second byte 16 hertz has been changed to 22 hex, show that how checking checksum detects the error. Okay. Now, for the first part, we have to find the checksum byte. Then the second part, B, we have to perform checksum operation to ensure the data is uh, uh, integrity. And in the third part, we have to that if this the second byte 62 hertz has 62 hex has, that is this one, has been changed to 22 hertz. Show that the checksum detects the error that if the second value is changed with this changed to 22 hertz, the 22 hex, then it would show an error. So first of all, the 25 plus 62 plus 35, 35 and 52, what would we do? We would be simply adding them and we get 1 carry and 18 hex. Then after that, we would be forming check hex operation to ensure the integrity, and it would be also the plus sign. But else we would be adding E8 hex in the end. And then we have to dropping the carriers means we get 0, 0, which means that data is not complete. In this question, the data is not completed, that's why it is used. Then after that, the second byte 62 is changed to 22, we would change 62 by 22 and we would check it again, and its answer would be 3. 1 CO hex. C0 hex means this will carry and head. Dropping the carry, we can get to the C6, C06, C0 hex value. That means that the data is compressed. Then after that we have the example number 29, write a AVRC code program to calculate the checksum byte for the data and given in the example 28. So in now whatever the example was given, and now we will write its code. So what happens that we assigned the character and make an array of my data, and we give all the 4 data that we had before, as you know. And then we what would we do? We would be making the sum is equal to the character sum, unassigned character sum is equals to 0, and then an unassigned character x, and then an unassigned character uh, ch- checksum byte, and then we would be declaring the directions over here. Then port B and port C and port D are all three are output pins ports, and then we would be giving, no one can give the input, so there would be no extended force applied to it in this circuit. And then what would we do? That we would be making port B, port D is equal to meta uh, a for loop. We would making for loop, and that book would be having only 4 digits. For x is smaller than 4, that means it's 3. So x is increment as well. From as x is starting from 0, it means 4 letters. Then port B, port D is equals to my data x. Then like one by one these data would be added. Then the sum is equal to sum plus my data x. So this function would be made for the addition of uh, all of the numbers that are given before, that are also stored in the array of my data. And then what will we do? We would be declaring the sum to port B. Now this loop will work unless and until all of the 4 the numbers are added. Then we would be taking a check sum made is equals to inverse of sum plus 1. We would be inverting it and adding it to 1. Then we would be displaying it to port C, and that's it, the code. Then what the example number 30, write a C plus program to perform step B of example 28, and that if the data is good, and send it to ASCII value of G to port D. Otherwise send port B to port send port B. Now what would we say, saying that if it's successful, then it send it to B, and if it is not, send it to port D. Okay, and write B, and if it means bad, otherwise we good, so send G to port D. Now what do we would make a unassigned character again, and my data, and then we would be initializing all of the 4 bytes, all of the 5 letters numbers. Then we would be making an unassigned character. Checksum is equals to 0. In the first example, we just made sum, and within this, we would be making checksum, and then unassigned character effect. Then we would be declaring the direction of 40, that is 0 cross FF, that is output. And then we would be using a for loop that x is equals to 0, x is smaller than 5, and x is increment. Then checksum is equals to checksum plus my data x. So it means that if the first starting it will be 0, so it would be having the 0, but as soon as it connected, it could also be able to win us. Okay, it would be enabled us to work accordingly. Unassigned character of x, then the direction DDRT is given to 0 plus FF, that is already explained. But if now if a statement after the checksum code checksum condition, we would be performing an if else statement. If the checksum is equal to 0, then it would be code would be G. Then if it is not, then it would be B. Then why would it the B do like that? So the reason is that or checksum is equal to checksum 0. So it could be 0 unless it until what would happen that the data is correct. Uh, it didn't give a right answer because it was checking the data's integrity. Integrity should be equal to 0, otherwise it would be not integrated. Then after that, example number 31, write an AVRC code program to convert 1111 and 01 FT hex to decimal and display it in the take it's on digits on ports B, port C, and port A. So what it is asking that we would be making this hex value into or binary value from ports to digits value and displaying it on all 3 ports, port B, port C, and port D. So let's start our circuit code, and that would be unsigned character effects is pin by D1, D2, D3, and we would be DDRB, DDRC, and DDRD is equal to 0 cross F. That means that it is an output port, and then output port, and then bin byte is equal to 0 cross F. That bin byte we made character first. We would be declaring its value as F. That is our initial given statement condition that we have to use this hash value and convert it into digits. Then after that we have made an x value is equals to bin byte divided by 10 to make it a digit value instead from binary. Then we would be dd1 is equals to initialize the j bin byte and checking for its remainder. The remainder ddr2 is equals to we would also x that is bin byte divided by 10. Uh, that is the divide by find remainder as well. Middle digits, we would be checking it for the middle digit, And for the D3, we would be checking it towards significant digit, that is the last digit, by dividing it by 10. Means that x first was checking for the remainder, and the remainder would be societal value. And if we divide directly bin byte with a 10, it would be checking for it would the first parameter and the last one. Sorry, and the last one. Sorry, it would be the first parameter, and the T3 would be the last and most significant digit. So after that, we would be displaying this on all three of the boards, and just like that, it would be displaying on all three boards at 1 2 3, like this. If this if we calculate FT, so if I show you FT in digits, if we see over here 2000 something, it is yes, I forgot to write zero cross, and then I'll go back. Okay, now it's fine. It's 253, so that's why it had to be it. The first letter would be declaring 2, the second would be declaring 5, and the third would be declaring 3. So after that, the example 32. So in this, write an AVR code program to send out the value for 44 hex serial number 1 a bit at a time via port C and pin 3. The LSB should go out first. Okay, so first of all, we would be simply doing that we define serial pin instead of using those. We use another pin of our library, and that would be serial pins. The serial pins that are on the RD inside an RD inside an area system. When we are study area system, we also study the concept of these serial pins, and now we would be using them for it. So unassigned characters the character con byto con byte is equals to 0 plus 4 4. Then unassigned characters are elsa reg a lsp reg lsp. Then unassigned character is s. Then reg assigned lsp is equals to con byte. So means that 0 cross 4 forward stored in it, and then we would be the DDRC is OR function, forming an OR function with first C2 smaller first serial bin, as it is written over here in the program that send out the value 44 hex serial number 1. Okay, that's why we have used one smallest serial pin. It is the way to use this serial pins, and we have used the first serial pin. So also it gives that it should give one at a time. So we what we do, we make for example for loop, and we make x in integer and character that was unassigned before. We use a 0, and then unassigned this character, initialize it 0 is smaller than 8, and increment this is our for condition. So what happens is this is for until the loop is created for this, and this loop will work unless and until this condition is satisfied completely. So after that, we would be right if like Ilsa is and 0 cross 0 1. So now we would what would we do? We doing that we would be comparing both these values. We would be forming and function on it, and then we would be declaring if the condition is correct, then it would be going to port C as with forming an OR function with one serial number pin, or else it would be not the reg port C would be inverted, and function will be inverted with the one serial pin, and reg elsa is equal to reg elsa smaller than 1. Then after that, example number 33, write a program if you have to send out the value of 44 serial number 1. Your time MSP should go first. Now first was LSP, but now it is MSP. So there would be only a slightly different change, and that would be instead of this lesser than 1, it would be greater than 1 value. So this would go out first. Then example 34, write a AVR program to bring in a byte of data of serial number 1 bit BR port 3 pin 3 SSB should go first. It is the same the condition that is asking, so we would be just going. But in this, it's a simple program. It is not asking us to make 1 bit serial number. Okay, it's asking us to make 1 serial number, but it's not asking us to display the value of 0 cross 4. So it is not given us 0 cross 4. So now what we do, if it is not given 0 cross 4, we'll simply define one variable, assign one unassigned variable, correct unassigned character x. Then we would be making an unassigned character h a is equals to 0. We are initializing its value is 0. Then we would giving direction or data C, and we would be performing the first bit. Means the first pin of the one serial pin would be on. Then we would be making a for loop with 0, same 8 bits, and is x plus plus. Then we are making reg 0, rega is equals to rega smaller than 1. And rega is not equals to pin C, and rega is equals to serial pin and smaller than smallest seventh pin. This will copy with serial number. This is the way to copy with serial number of port C to MSP of Rega Mega. Then after that we would be performing the next example, that is 35 in a AVRC program to write a bit in a bit of data serially 1 bit of at a time via port C, and 3-bit MSP should come first. Now again it's MSP. Now it is also not giving us. Now the first for a few example it was giving us a 44 value, and then it was asking us to exclude display the MSP for MSP or LSP first, and now it is not giving us 44, and instead of 44 it is asking us to do it. So in the first one, it is there also there would be one change of it. There would be an greater to sign and before, and serial pin only, not 7 pin. So in this, it was smaller than 7 minus serial pin. So that is also 1. So that's why it was giving an MSP, LSP first, and now it is giving MSP first. Then after that we have example number 36, that is a second last example, and we would be write an AVRC code to store G into the location 0 cross 0000 F5F of EEROM. EPROM, and EE electron, that is a type of ROM. And now it is asking to us to write a C plus code to store G in this location of 0 cross 005F. So what we will do while to write this program, the same the area the direction for the C would be remaining the same, but what will happen would be that the commands would now we have to use the commands of that while loop EERCR, and that one is small of EEWE, that wait for the last write to first. Now we declare EEAR value is equals to 0 cross 0005F, and then EADR is the value is G, that writes G data register. We are writing we are storing these values in these variables in these commands, so that addresses so that registers so that we could store them after, and then we could use it ahead. Now, the while loop which we had used cr is not equal to that. Sorry, it's we were performing an OR function with mwe to write 1 to m. EEMWE a command register, but then we would be forming if or function again with EEWV that start EM to write. That first one was command was to write one in it, and the second one command was to write start EE from to write now. Okay, the last example is example 737. In this is a write a CUR code to read the content of location 0 cross 00F5 5F of EROM into port B. So port B can so what we have to do that port B we 0 cross 5FF we declare it as output. Then after that we while uh, what we do that ERCR the command we take and WE so it means that it is used for the last write to finish. It is used for the writing purposes. And then EEAR command we use the EEAR command to store the location, and that is 0 cross 00 effect. And then we will form the as we do not have to write in it, we simply have to uh, read it. So we instead of W we use R, and that start from to read by writing EERE. Then port B we would display the value that is stored in EERE, means whatever it has read it would store the value and show the value, display the value of in the port B, and move the data from port B. And that's it. The next chapter is ended. All examples